Welcome to It's Good to Be Smart. I'm your host, Dr. Dave Mulder. I love to learn new things, and I hope you do too, because it's good to be smart. Today we're diving into the fascinating differences and surprising similarities between physical and chemical changes in matter. But first, let's recap what we've learned so far in our series about matter. In episode 1, we asked the big question, what is matter? And we discovered that matter is anything that takes up space and has mass. In episode 2, we got to the heart of the matter, atoms. Atoms are the building blocks of everything around us. Episode 3 was all about properties of matter, the characteristics that help us identify and describe different substances. And in episode 4, we explored how we can mix matter together to create mixtures and solutions. You can always run back to catch up on episodes you've missed, or listen again for a refresher on those ideas. But now, it's time to build on all that with an important concept, understanding changes in matter. Are you ready? Let's go. So, what exactly is a change in matter? A change in matter happens when something about the substance, its appearance, its structure, even its identity, is altered. These changes fall into two categories: physical changes and chemical changes. This connects back to the idea that substances have both physical and chemical properties, and we can observe changes in either of these types of properties. Let's start with physical changes. A physical change affects the form or appearance of a substance, but it doesn't change what the substance is. In other words, the substance stays the same at its core. Think about these 5 examples. Example number 1. Melting ice into water. It's still H2O, it's just in a different state. Example number 2. Tearing a piece of paper. It's still paper, even though it's in smaller pieces. Example number 3. Stretching a rubber band. The rubber changes shape, but it's still rubber. Example number 4. Breaking a piece of chalk. Well, the chalk is in pieces now, but its composition hasn't changed. Example number 5. Mixing sand and water. The sand and water stay separate substances even though they're mixed together, and we can separate the mixture back into sand and water. These changes are often reversible, which is another clue that they're physical changes. But now let's consider chemical changes. A chemical change, also known as a chemical reaction, happens when substances combine or break apart to form new substances. This means their molecular structure changes, and you get something entirely new. Here are 5 examples of chemical changes. Example number 1. Burning wood. The wood turns into something else: ash, smoke, and gases, new substances. Example number 2. Cooking an egg. Heat causes the proteins in the egg to undergo a chemical change, creating a new structure that's a lot more solid and way less goopy than the raw egg. Example number 3. Rusting iron. Oxygen reacts with the iron to form rust, a new substance. Example number 4. Digesting food in your stomach. The acid and enzymes in your stomach chemically break down that sandwich you ate for lunch into different, simpler chemicals that your body needs for energy and raw materials. Example number 5, or the classic vinegar and baking soda reaction. When you mix them up, they fizz and produce carbon dioxide gas, a chemical reaction in action. These changes are often irreversible. They usually involve clues like a change in color, or the release of heat or light, the formation of a gas like the bubbles in the baking soda and vinegar reaction, or the formation of a solid like the rust in the iron and oxygen reaction. Why make a big deal about the differences between chemical and physical changes? Because to understand what matter is, and how we can use different forms of matter for really interesting things, we have to be able to distinguish between these kinds of changes. Both involve changes in matter, and they can both look dramatic. For example, ice melting and wood burning both involve noticeable changes, but one is physical and the other is chemical. If the particles the substance is made of stay the same, then it's a physical change. If the particles get rearranged to form something new, it's a chemical change. Before we wrap up, here are a few surprising facts about physical and chemical changes. Some chemical changes are really dramatic, like when fireworks explode. The variety of colors you see in fireworks are made by different chemical reactions that take place when the materials inside the firework burn in the sky. Not all chemical reactions are so showy and obvious, though. Some are really subtle. For example, when an apple turns brown after being cut, it's undergoing a chemical change due to the oxygen in the air. And some changes can be both physical and chemical. For example, when you light a candle, the wax melts. That's a physical change. And the wax burns. That's a chemical change. Popcorn popping is another example. When you heat a kernel of popcorn, water inside it turns to steam. That's a physical change. And the starch inside it undergoes a chemical change to form the fluffy texture. So your movie snack is actually science in action. The big thing to remember about physical and chemical changes is that physical changes can usually be undone, but chemical changes cannot. Both are super useful for people who are working to solve real-world problems. Scientists use physical and chemical changes every day. For example, scientists use physical changes in the ways different proteins can fold up to create new medications that treat diseases. Or here's another example. Scientists researching chemical properties of different kinds of ceramics have developed substances that don't burn up when they pass through Earth's atmosphere. And if you coat a rocket with these, you can safely return astronauts from space without the fear of them becoming a fireball on re-entry. Pretty smart, right? Thanks for joining me for this episode. Nice work leveling up your brain power today. Remember, smart isn't something you are, it's something we become as we're learning. So keep listening, keep learning, and keep getting smarter every day. It's Good to Be Smart is created and produced by me, Dr. Dave Mulder, with the support of the National Science Foundation through a Robert Noyce educational grant. Subscribe to this feed so you'll never miss an episode, and check out our home on the web, goodtobesmart.com. And until next time, keep asking questions, stay curious, and keep learning, because it's good to be smart.